All right, this problem is I got two speedboats, one the Gregorian Special and the other is a Max Supreme. The Gregorian Special has massive acceleration, so it's going to get off to a quick start. It goes 21 meters per second squared until it gets to 42 seconds, 42 meters per second, which would only take it 2 seconds, right? Because it's going to 21 and then 42, and now it's at 42. And then the rest of the race, it's at the top speed, going as far as it can. So that's how far the race is for it. That's how it does the race. Okay. The Gregorian Special, on the other hand, much slower boat, acceleration-wise, but somehow it has the ability to go much faster in the long term. And so it's going up 8 each time. So 1 is 8, 2 is 16. So its acceleration tells us that at 8 seconds, I'd be at 64. Now take a look at these two graphs, and the features are we have a triangle followed by a rectangle. Looking at that, I'm going to be interested in where the triangle stops, because that's about where they'll likely catch each other. So I'm really interested about 8 seconds in. Okay? So looking at the 8 seconds, I'm going to start building myself a cute little table. Table, distance of the GS, and distance of the displacement, and probably just distance of the Max Supreme. Okay. And I'm going to start at 0, 0, 0. That's great. We go 8 seconds. Now, there's some chance that it's going to be over before 8 seconds. So I might guess that I might have to have it down lower. Take a look. 8 seconds. So this right here is going to be 1/2 2 times 42 plus 6 times. Now I get the rectangle right. So it'd be 6 times 42. If I do that really quickly, I get 294 meters. 294, and that's the Gregorian Special. Double checking out 294 meters. Okay. Now I go and look at the Gregorian Special. The Gregorian Special is just one big triangle, so that's going to be 1/2 8 times 64. It's 256, I think. Yeah, 256. I mean. Okay. And so that's going to mean the distance between them right now is 38 meters. Okay? So this moment, this very moment, the Gregorian Supreme is still in the lead. Okay? The Gregorian Special is still in the lead. Accelerated faster, it's going slower, so the Max Supreme is going to catch up to it, but the question is, where is it going to catch up to it? Okay? So a couple thoughts. It's going constant speed after this, so we can do our little constant speed thing and hope for the best. And that's good. What if I do 9? 9 is like a reasonable number. 9, I'm going to go 42 more. So 42 more would give me 336 meters. And then this would be 64 more, so that's 320 meters. It's down 16 meters away. So in this gap right here, I gained 22 meters closer, and I realize, gosh, I don't need a whole nother second to catch him because I'm only 16 meters behind. So the question is, what number am I going to pick? Okay, so I'm going to pick some random number. I might pick 9.5 and hope for the best. Why 9.5? Because I think 9.5, I can figure out what 42 times 0.5 more added on, right? I'm adding a little tiny sliver of a half a second. Maybe half a second times 42. That's only 21. So that would be 357 meters. And then if I try to do the Max Supreme over here, I would notice that's 64 divided by 2 is 32. So that's 352 meters. And I'm still short. I'm 5 meters away. But I am really close now. So I might at this point kind of cool my jets and say 9.6 seconds, which is 0.1 more. Now 0.1 seconds times 42 is going to give me 4.2, right? 4.2, because I'm adding just 0.1, and I'm going at 42, so that's 0.4, that's 4.2. So 4.2 would give me 361.2 meters. And I'm going to look at the Max Supreme. I'm adding 6.4 to it, because same reasoning. It's going 64 meters per second, 4.1 seconds. So 6.4 would give me 358.4 meters. And the gap is narrowing. it's about half the distance right there. So I'm going to go 9.7. Thinking maybe I'll catch it on that end. 9.7 means I have to add another 4.2, which would be 365.4 meters. And if I do 0.1 more here, that's 6.4 more. So that would be 8, 4, carry the 1, 364.8, and I am so close, it's frightening, but I haven't caught it yet. So 9.8 meters would be a good choice next. I'm going to add another 4.2, and that's going to give me 369.6 meters. And then for the max supreme, I'm going to add 6.4, that's 2, carry the 1, 71.2, 371.2, check. The max supreme is now past it. So what distance would the max supreme win at? So the max supreme is going to want a race that is 370 meters, because it knows it's going to get to 370 meters before the Gregorian special. So you're looking at 370 meters is what distance you're going to want it at. Okay? Approximately. Could you narrow this down? Sure. How long do you want to take? If you add up 0.01 to it, 0.01 times 48 would be 0.48, and you can get this really, really fine, gritty thing. But this is sufficient for the accuracy of this model. It's only good at 2 digits. I'm going to give you a race. It's 370 meters long. That's 2 digits. In fact, I would say 370.37 with a 0 line over it, which is actually more accurate than the data would suggest I'm allowed to have. So both of those would be fine. All right? So that's the way you could approach this problem, and it would work just fine. Again, if you see a mathematical model and jump to it right away, not the worst thing. Like the truck, the police car, and the truck problem, it would work for that. Number 6, which is the last of our fun-filled testable fun, is also an interesting problem. It's a fair problem. It takes a moment to figure out how to even approach it, though. Okay, so your thinking should be something along the lines of, well, I'm going to do a velocity time graph. And what? Doesn't give me initial velocity. That's what I'm solving for. So I know I'm starting with some velocity, and I'm going to slow to a stop. So my graph's going to look like that. I know my slope here is going to be down 0.1 each time, right? Because I'm slowing down. Accelerates this slope at -0.1 or 0.1. And last but not least, the area of this little area has to be, because it's a velocity time graph, and because I want it to go 50 meters so I can win the contest, this has to be 50 meters. Problem is, I don't have any way to do this now. So here's what you might do. You might say, oh, look, I'm going to start out by guessing a number. What's a reasonable number? I have no idea, so I'm going to start with 1. If I start with 1, I'm going to notice it goes down 0.1 each time. So at 1 second, I'd be at 0.9. At 2 seconds, I'd be at 0.8. Hopefully, fairly quickly, you realize counting down, or you can count down all the way. You're going to get to 10 seconds. And so the area of this thing is going to be 1/2. 1 times 10. And you look at that and go, oh, that's just 5. And that is really not good enough. And then you might go, okay, let's try 10 seconds. Let's try 10 meters a second, because that was really low and unfortunate. Now, if you're going down by 10, you're going down 0.1, that's 9.9, 9.8, 9.7. It's going to take you 10 sets of 10 seconds or 100 seconds to stop this vehicle. I hope you have to count by 0.1s, because that would take forever. So then you look at this and go, well, that's 1/2 10 times 100. And you would get 500 meters, which is unfortunately very high. Now, at this point, if you have not gotten to this point and then you started the video and you just stopped the video, I'm going to pause it in this moment. And I'd like you to keep going, okay, until you get stumped again. When you get stumped again, turn this back on and I will bail you out, okay? So pausing in 3, 2, 1, 0, going to start again. Here we go. So hopefully you paused it, or you were past this point and you really didn't need help with that part. Okay, so I'm going to guess another number. So I'm going to guess another. I'm going to guess something like 4, because that's about halfway between or some such thing. It's a nice even number. And this gets me down to 40. Now, I did that really fast. Why did I do that really fast? Well, because I've noticed that when I'm up 1, it takes 10. If I'm up 10, it takes 100. I'm really it takes 10 times as many seconds to stop it as the height I randomly picked. And so this would be 1/2 4 times 40. and that's going to give me 80 meters, and it's still too big. So now I'm going to go to 3. I got 3, and then I'm going to go, let's go 2, actually. Let's do 2 and 20. Do this, and that's 1/2, 2 times 20, and I got 20 meters, which is way too little. So I'm starting to get tired of guessing here. You might notice the following. Whatever I pick here, it's 10 times as far here. Okay? Now I can keep doing this and get to the right answer to the 3 digits I need to get to, but that's going to take a really long time. Perhaps what I should do instead is I should go, well, whatever I pick, let's call it V naught, because that's what initial velocity formula is. This time it's going to take down here would be, and I'm going to wait a moment for you to think really hard. When it's 1, it's 10. When it's 10, it's 100. When it's 4, it's 40. When it's 2, it's 20. So if it's V naught, it would be 10 times V naught, right? So this is going to end up being 10 times V naught, which means the area is going to be equal to V naught times 10 V naughts times 1/2, because it's a triangle, right? And if that's the case, then 5 V naught squared would be equal to the area. And I want the area to be equal to how far it goes. We want it to go 50 meters. So I set it equal to 50. And I get V naught squared equals 10. And I put that in my calculator. V naught equals, to 2 digits, 3.2 meters per second. With 3 digits, more like 3.17 off the top of my head. I might be wrong. And that would be the answer with 3 digits, which would satisfy the requirement that we start with 3 digits and have 3 digits. Again, could you get there by going, okay, let's try 3.1. Sure. 3.14, 3.15. Yes, you could absolutely do it that way. At some point, you should jump ahead. These are hard problems. If you think these are hard problems, that's fair. But again, the idea is you start modeling until you can kind of figure out, okay, let's not guess 100 numbers. Let's figure out what math is behind it. And then you can figure this out much quicker. Again, if you're stuck guessing, guessing works. It won't hurt you at all, except it takes a long time. Okay? All right, this should handle both problems 5 and 6.